Coterminal angles are angles that have the same initial side and the same terminal side, but different measures. You may wonder, how could that happen? But it can. So, for example, suppose I have an angle that's 70 degrees, and that's ballpark there. It's in quadrant 1. I started on the positive x-axis and ended at the terminal side in quadrant 1, and that's a 70-degree angle. But that's not the only way to get from the positive x-axis to that terminal side. I could have gone around the other way. If I do that, now that angle has negative measure because I went the opposite direction. I went clockwise instead of counterclockwise. What's the measure? Well, let's see. If I had gone all the way around clockwise, I would have an angle of negative 360 degrees, but I didn't. I stopped right here. I stopped 70 degrees short of a complete revolution. So that's, let's see, negative 360 minus 70, that's negative 290 degrees. Same initial side, same terminal side, started and ended the same place, but the degree measure is different. So negative 290 and positive 70 are coterminal angles. Still not the only way to get there. Here's my 70-degree angle. I could get there just by going, directly the shortest route, or I could start on the positive x-axis, go all the way around, and then end at the same terminal side. Not the same measure. I've gone a lot farther. I've gone my 70 degrees plus an additional 360 for a total of 430 degrees. So 70 degrees and 430 degrees are coterminal angles. They're not the same angle. They have different degree measures, but same initial and terminal sides. So we'll call them coterminal. So the way we can get angles that are coterminal with a given angle is by adding or subtracting multiples of complete revolutions, multiples of 360. Or if we happen to be in radians, complete revolutions, we're going to call 2 pi. Pro tip, your answer should look like the question. So if the question is, what's an angle that's coterminal with 70 degrees? You're going to tell me 430 degrees, so that the units are the same as the question. If I want to know what quadrant is 50 pi over 7 in, the answer needs to be in radians, not degrees. The answer should look like the question. So let's see. And what quadrant is 50 pi over 7? I don't know. I know 2 pi is all the way around. And, this is 50 pi over 7. It might be nice to know what is 2 pi if it had a denominator of 7. I'm going to be adding and subtracting multiples of 2 pi. Common denominator, all that fun stuff still applies. So let's see, that's 14 pi over 7. Yeah, I don't know. That's more than 2 pi. 50 pi over 7 is a lot more than 14 pi over 7, so I can't tell. But we can find coterminal angles, which will start and end in the same quadrant as my original. So I'm going to take my 50 pi over 7, and I'm going to subtract 14 pi over 7, and that gets me still too much. So I'm going to take that, and I'm going to subtract another complete revolution. I'm going to subtract another 14 pi over 7. I couldn't decide if it wanted to be a pi or a 7. And now we're down to 22. All right, that's still too much. I still don't know. So I'm going to do it again. I'm going to subtract another complete revolution, another 14 pi over 7, and get, oh, that's better, 8 pi over 7. Okay, well, 8 pi over 7, I know that 1 pi or 7 pi over 7 is halfway around. 8 pi over 7 is a little bit more. 8/7 is a little bit more than 1, so I'm going to keep going a little bit more, but it's not all the way around to 3 pi over 2. So my terminal side is somewhere in the wilds of quadrant 3. It doesn't really matter where. The question was, what quadrant are we in? We're going to land in quadrant 3. If I happen to want to know a negative measure for a coterminal angle with this one, I can subtract that 2 pi one more time. 8 pi over 7 minus 14 pi over 7. So this angle is coterminal with an angle whose measure is negative 6 pi over 7. So I could go in the negative direction, negative 6 pi over 7, or in the positive direction counterclockwise, 8 pi over 7, and get angles that are coterminal with 50 pi over 7.